Hello class, today we're on lesson number 3. On page 406 we're in chapter 9, polynomials, and we're going to move on now that we've learned polynomials. We're going to learn a little more about adding and subtracting polynomials. So let's take a look here. We have a cartoon up here with Charlie Brown and Lucy, and we read, "We learned in school today that there are 16 ozzes in a lib. We've been studying pints and quarts and feet and inches and ozzes and libs. I get kind of confused on quarts and feet, but I'm good on ozzes and libs. Do you know that there's 16 ozzes in a lib?" And then Charlie Brown says, "I never know how to answer a question like that." Now, what she's referring to obviously are ounces and pounds, okay, and those are the unit, the abbreviations that are used. But now let's take a look at what are they referring to here. And I think this is a good example when we're talking about units of measurement and how we can add units of measurement. It's pretty similar to how we deal with polynomials and how we deal with the monomials of different degrees. So let's take a look. In the 16th century, King Henry VIII of England decreed that a pound was equal to 16 ounces, and so it is still today. Since then, it has been customary to express many weights in combinations of two units. For example, if Charlie Brown stepped onto a very precise scale, he might read his weight as 80 pounds 12 ounces. If the scale gives Snoopy's weight as 11 pounds 3 ounces, what would the scale read if both Charlie Brown and Snoopy stepped onto it at the same time? We can answer this question by adding the two weights like this. So we have 80 pounds. Let's go ahead and put this up on a board so we can see how they're doing it. So we have 80 pounds, all right, and plus 12 ozzes or ounces, as Lucy was saying, that those aren't ozzes and certainly not libs. Then let's make this 8 a little more of an 8. Okay, that's a funny looking 8. But nonetheless, let's move on to 11 pounds and plus 3 ounces. So we have the two weights. We have Charlie Brown's weight and we have Snoopy's weight, okay? And so if we were to add these, we know that we would simply add each the pounds and the ounces separately. Couldn't add them all together because they actually represent different units of measurement. So we would add the 12 and the 3 together. We would have 15 ounces. And we would add the 80 and then the 11, and that would give us 91 pounds. So we could, actually here, LB. So we could say that 91 pounds, 15 ounces is their weight combined. Now, two or more polynomials can be added in the same way. They can be written in a column so that, like terms, those that have the same degree and variable are in line. Each set of like terms is then added. For example, suppose we want to add two polynomials such as, and let's go over to the side here, we have 4x squared plus x plus 5. And we wanted to add that to x squared minus 7x plus 3. Okay, now we could have written this all the way across like we did in our previous lesson when we had a bunch of like terms all kind of bunched up in one long line. We can certainly do that, but it's a lot easier when we visualize it this way. In fact, in some cases we may be missing certain variables, and we're going to learn how to also write those in one of our examples here. But what we would do is just simply add up the like terms, and that would give us 8, right? That's positive 8. Now notice I am definitely going to be using positive and negative. Remember that we're looking at these as terms, positive and negative terms. So it's very important that when we're adding them, even in this method, that we look at them as positive and negative. Okay, in this case, we already did that here. Positive 5 and positive 3 is positive 8. So here we have positive x and negative 7x, and as you can see, they write plus negative 6x, and we're just going to write negative 6x, okay? And then lastly, we have 4x squared and x squared, and added those two together. They're both positive, would be 5x squared. So here, this would be the sum would be our polynomial 5x squared minus 6x plus 8. Now, the same method can be used to subtract one polynomial from another. Okay, here are more examples on how polynomials are added and subtracted. So we have quite a few examples here that we're going to go through. Okay, and just going to clean up my board here for a second. Okay, I magically cleaned it without you even noticing it. How's that? I guess that's the power of pause on my video. Now, let's take a look at our first example. We're going to add x cubed. Let's write this out now. And we have to be very careful when we write that we do not transpose minus 7x squared and minus 1. And we're going to add these two, and we have 3x squared plus x 8x. Now, before we do this, before I write these, I don't really need to write down the problem, because we see here that we're going to actually have to make up a little bit of room here for a missing degree, and let's explain why. If we take a look at the solution, we're writing them so that they would line up in a column. Now, we don't have a cube in our second, so we have 3x squared plus 8x, but we have a 3x squared. We would write it here, 3x squared. All right. Let's rewrite this. That x needs to look more like an x, and that's x squared. And again, that's a positive 3x squared. We don't need to do that, but in this case I'll do it so you can actually see it. And we also have plus 8x. Now notice that we don't have an x variable, or x to the first degree. So we're going to leave a little space there, and we're going to put -1 over here, or -1. So here we have this x cubed minus 7x squared. There's some space, but then eventually we're going to subtract the 1. So it's kind of just space there. And it allows us to line these up in a way that we can see them better. Okay, so what do we have? Well, we have x cubed, we have a negative 7x squared, and we have a -1. And over here we have a positive 3x squared and a positive 8. Okay, now we're going to add these, and you can put a plus sign here if we're adding. If we're subtracting, we would put a minus sign there. And so we're adding -1 and nothing, so that would be -1. Okay, and let's go on, and what do we have here? 8x and nothing. So we could certainly put plus 0 here, and we can put plus 0x, actually, because that would be 0. It would be nothing, right? So we would have 8x. And this is going to be important later on, that you understand that you can do this, because later on you're going to need to sort of represent something that's missing. It'll help you, particularly when we get into something a little more complex like dividing. Okay, so that's a little sneak peek into what you could do, but even if we don't have it when we're adding it, it's quite simply 8x here. Now we have -7x squared plus 3x squared. That will give me -4x squared. And lastly, I have x cubed, or positive x cubed, so that's all I have there. Okay, so that gives me the expression now, x cubed minus 4x squared plus 8x minus 1. Okay, so that's that example. If we look at the next example, we're to add 2x plus 9y and x minus 4y. Oh, so we have another variable here that's popping. The y variable is showing up. Okay, so we have 2x plus y, and we have x minus 5y. So again, we're going to always try to line up the like variables, or actually like terms, and for that, remember, we need to have the same degree and the same variable. Okay, so in this case we do have x and y, and we need to make sure that we have our x's lined up and our y's lined up. Okay, so that's really what we're doing here. So I'm going to add 2x to x, and I'm going to add, well, we're adding here. They did ask us to add. Let's put the plus sign. And we have 9y, and we have negative 5y, and that gives me positive 4y. And we have x, positive 2x, and positive x, which gives me 3x. So the answer is 3x plus 4y. So that one was pretty simple. Let's move on to the third example. And in this example, we're going to add, and again, something a little more complex here. We have x to the fifth plus 3x, and then we have 4x squared minus 2, and then we have x squared minus 7x. Now, let's read here. It says, in this example, we will do this problem horizontally instead of vertically, because we can. Typically, we're not going to have that opportunity to always put things horizontally. In fact, when we first learned to add, and you remember your first little, maybe you had flashcards and you had 8 plus 2. Okay, I'm taking you all the way back, and you had a little flashcard, and you had to give the answer, and you raised your hand and you said the answer is 10. Okay, so we did things vertically to help us understand, but it is good, particularly in the beginning, and we'll kind of go back and forth with it. But we need to look at things horizontally just as well, because that's how our problems are going to be presented to us. So it's going to help us to be able to have a keen eye towards these terms as they're presented in problems. So let's take a look. We could write them, and I like the way they put their parentheses first, just to sort of show you each of these expressions and how they're presented. So we have x to the fifth plus 3x, all right, plus. Now, since we're adding all these, it really has no effect on what's going on inside of these parentheses. We could really write this without. If we were subtracting, it would be different. Be very careful with subtracting. I've mentioned it before. But we're going to just show this so you can see them grouped as they were presented to us. We have x squared minus 7x. And the question is, what does this equal? Okay, we want to know, what does it equal? Well, again, we're looking at parentheses, and we could simply strip away the parentheses as they did. Okay, now I'm not just going to rewrite this all, but I am going to now start looking at like terms and grouping them so that I can add them more efficiently. Okay, so I have x to the fifth. Is there another x to the fifth? No, but I'm going to write this in descending powers. Oop, I'm sorry, I put x squared. It's x to the fifth. Okay. So what would be my next x to the third or fourth? There's no x to the fourth. There's no x to the third. So my next one would be x squared, and that would be 4x squared. So I'm going to add. Now, I guess maybe I should just pause for a minute, because I did show you in the beginning that we should very likely use this boxing out, and I'm not boxing out right now. I'm really kind of looking at my page here, and I skipped over that step. But what I'm going to do, just to make this a little bit easier for us to visualize, I'm going to go ahead. Oops, I'm sorry, can't remove it that way. I'm going to go ahead and remove these. I'm going to pause the video so we can see this without. Hold one moment. Okay, so I've gone and I've removed the parentheses. You see how they just disappeared, and we can see that this is really representative of the second line. And the reason I did this is because I should just try to be consistent and try to get you to understand that these are individual terms, positive and negative. So why don't we go ahead and identify them? And so we did the positive x to the fifth. Now we don't have a fourth power, we don't have a third power, but we have a second power, so I have plus 4x squared. So let's write that here, plus 4x squared, or positive 4x squared. Okay, and I also have another x squared. I have a positive x squared here, so let's write that down, positive x squared. Okay, then I have to go back now. I have no more squared to the first power, 3x. So I have positive 3x. That's positive 3x. And I have a negative 7x over here. Okay, so negative 7x. And lastly, I have a negative 2 just hanging out there. So we've rewritten this entire expression, this polynomial. We've placed them in descending powers, which makes it a lot easier for us now to add. And that's really the purpose. One of the purposes is to help us to add and subtract these things horizontally. So let's take a look. But it also helps us in factoring later on as well when we see things. So we have x to the fifth. There's nothing here to add, but we do have x to the fourth and x squared. I'm sorry, 4x squared and x squared. So we can add those two. So we have, oh, let's rewrite that. We have x to the fifth, and this would be positive 5x squared. And then we have positive 3x and negative 7x, which will give us negative 4x. Again, we're looking at these in terms of their positive and negative values. Positive 3x, negative 7x will give me a negative 4x. And then we have minus 2. So the answer, when we add these, is x to the fifth plus 5x squared minus 4x minus 2. So that would be the answer to example number 3. Let's go on to example number 4. And again, we have subtraction now. 3x plus 10 and 5x plus 4. Now we're going to go ahead and write these vertically. And I'm also going to show you something. Well, we're going to have that in example number 6. We're going to do that horizontally. And this is going to be one of those examples when we get to number 6 where we have to be very careful with our parentheses. So we're going to subtract 3x plus 10. Now, notice that this isn't negative 3x right now. This is just, we're showing this as a vertical form of adding or subtracting. So we're subtracting the bottom expression from the top. So let's subtract 10 from 4. Well, if you subtract 10 from 4, it's going to create a negative, right? It's negative 6. So we have 4 minus 10. And we also have 5x minus 3x, which would give me 2x. So the answer to this is 2x minus 6. And again, they show you where they simply keep the addition and they turn it into positives and negatives. We've done that before. Okay, I have no problem if you just went straight into it this way. But remember, you're subtracting the bottom from the top. And not the top from the bottom. So if I would have taken 4 from 10 and put positive 6, then I wouldn't have been subtracting the way I've written it. So, okay, now let's take a look at example number 5. We have 7x squared minus 9, and we're subtracting that, all right, from 10x squared plus x plus 2. Now, I probably should have noted that if we read, going back to example number 4, we're subtracting 3x plus 10 from 5x plus 4. So we're subtracting this from this. So if I subtract 5 from 10, you wouldn't say subtract 5 from 10. You wouldn't write it that way. You would have written, well, I'm subtracting 5 from 10, so I have to put what I'm subtracting is on the bottom, and I'm subtracting it from 10, then I would have written it that way. So be careful as to how you construct your your problems and make sure it's reflective of what they're telling you. Now we're reading here, subtract 7x squared minus 9 from 10x squared plus x plus 2. So we see here what they did was they started with the second one because we're subtracting from it. And so we have 10x squared plus x plus 2. And we're subtracting, let's go ahead and just put our big subtraction sign here, minus 7x squared and minus 9 all the way here. Okay. Now you could see where they used the plus negative 9. We can do that Okay, I feel confident that you'll be able to handle it either way by just looking at this. Now, it gets a little tricky here. Remember, and we're going back to some of our earlier lessons on how to add and subtract negatives. And remember, we have a negative being subtracted from a positive, and that's a little tricky. The mind just doesn't want to think straight. So we have 2 minus negative 9. Now, if we said 2 minus 9, we know that it would be a negative number, right? 2 minus 9. If we wrote this as 2 minus positive 9, we knew that that would be a negative 7, right? But this isn't what we have. We have 2 minus negative. And remember, when we subtract the negative, it's like adding a positive. It's the simplest way that we can say. We subtract the negative, it's like adding the positive of it, which means 2 minus negative 9 is actually going to be positive 11. Okay, now over here we are not subtracting anything from x, so we end up with positive x. We have positive x minus 0 would be positive x. And then we have 10x squared minus 7x squared. Well, that would give me 3x squared. And you're going to get used to this. Remember, when we're subtracting, just putting a little emphasis, we're simply subtracting the coefficients here. It's 10 minus 7, which is 3. And it's x squared because it's the same variable and the same base. Okay, so that stays the same. We're just simply going to say 10 minus 7, and that's 3x squared. So our answer would be 3x squared plus x plus 11. Now let's move on to our very last example. And this one is, again, one of these tricky ones. We got to be careful when we're subtracting, when we use that negative. And we're going to subtract x squared minus 6 from 2x cubed minus 5x. Now, if we were to write this vertically, we might have written it in this fashion, especially making room or allocating a little room for the x squared in the second one that we're subtracting. So we have 2x to the third, 2x cubed minus 5x, and we're supposed to be subtracting, and there would be the x squared here because there is no x squared, so we'll put it there, and this would be minus 9, right? So again, this is how we would do this if we were handling it vertically. Now they're going to do it horizontally, and that leads us to something very important, and this is probably one of the biggest pitfalls that we have with math and with algebra is when we're subtracting something within a parentheses. So let's write it in parentheses form. We would have written this as parentheses 2x cubed minus 5x. And we're going to close that parentheses, and now we're going to subtract this from parentheses x squared minus 6. Now, the reason this becomes a bit of a challenge is that unlike addition, where we can just simply drop the parentheses, we're subtracting. And just remember that when we're subtracting this entire polynomial, or in this case it's actually a binomial, we'll learn that more later, but we have a polynomial. Every term in here is actually being subtracted, because remember, we would actually add all of this together. Okay, so if I had 10 minus 5 plus 2, okay, order of operations says you better add these two together first, right, because of the parentheses. So that would be 10 minus 7, right, and that would be 3. Basically what we did was we took 10 minus 5, which is 5, and 10 minus 2, which is now 5 minus 2, which is 3. Right? So we were actually subtracting the 5 and the 2. In total, we subtracted the 7. Same thing happens up here. Now, it's much more complicated because we have variables and there's complexity to this, but it's still the same principle, the same concept. We're going to subtract everything here. And in order to do that, we actually have to then rewrite this. So let's go ahead and rewrite it as they showed us. And one of the things that they're doing is they're changing this to addition. And when you change something to addition, you have to go with the opposite. Okay, so let's see if we remember that. So we have 2x cubed minus 5x in parentheses. We're going to change this to addition. Why? Because then we can just strip out the parentheses without a problem. But when we change something to addition, we have to go with the opposite, remember? So we're going to go with the opposite of x squared, which is now negative x squared, and the opposite of negative 6, which is positive 6. So you see what we did? We changed everything. This went from positive to negative, and this went from negative to positive. Very, very, very important that you do this. I could probably show you a couple of other ways. I'll show you that possibly in the classrooms if we have a time. But here is an opportunity for us to just pause for a minute and understand this is your biggest pitfall. If you don't do this, you're going to end up with some really bad problems, particularly as it relates to, let's say, chemistry. If you're using algebra there, you really have to be careful with this. Now, if in algebra, in Algebra 2, you're going to have a lot of this. So your problems will always come out wrong if you don't apply this properly. And you're going to wonder why. You scratch your head and say, oh, I did not convert these. So now we can just strip out the parentheses and say 2x cubed. And before I say that, you might say, well, here we had order of operations, right? We could simply add these two, and we get 10 minus 7, and there's the answer. But here we have variables, and because we have these variables, we're not able to add or subtract 6 from x squared and give one expression for that. That's in its simplest form. But we know that when we're combining them here, we want to be able to express this all as one polynomial, remove that expression, and sometimes we do have opportunities to put like variables together or like terms, and with the same variable, same power, and if we were able to do that, well, we can simplify the problem even more, obviously. So we have 2x cubed minus 5x, and we just pull out parentheses here plus, I'm sorry, it's not positive, plus, and I'll write it like this, negative x squared plus 6, right? Now we know that plus negative x squared is going to become minus x squared. All right, so that's what we would do here. So let me just turn that around. Just put minus x squared plus 6. Okay, we just stripped it out. Now we have to put this in descending powers, and if we do so, we would have, let's see, we have here 2x cubed, we have negative 5x, we have negative x squared, and we have positive 6. So these are our 4. So let's put them in. X cubed would be first, or 2x cubed. We have negative x squared comes second, negative 5x comes third, and positive 6. So our answer is 2x cubed minus x squared minus, minus x squared minus 5x plus 6. So that concludes our lesson number 3.